In lesson 7, we're going to derive the demand for health insurance. Now, before we do that, I want you to click on this article, read it, and as you read it, try to find the words and phrases to fill in these blanks. And then after you're done with that, think about these rhetorical questions. Is this guy the president of the Society of Actuaries advocating for health insurance firms to engage in illegal discriminatory behavior? Are there consequences to mandating insurance companies charge males and females the same premium? Should young people pay the same health insurance premium as older people in their 40s and 50s? Is it fair to ask them to pay more so the older people can pay less? Now, in other industries, charging two different groups of people two different prices is rather common. You see it with movie ticket prices. Families tend to go to matinees. Younger people go to the evening show. The two prices are different. Same exact movie, two different prices. Seniors get discounts on coffee or food. So it's pretty common to charge different groups of people different prices. Is it fair for insurance companies to charge two different groups of people different health premiums? Now, think about those questions as you work through this problem. Now, as you work through the problem, you want to calculate your answers in Excel and then round them to 2 decimal places, unless in the problem I specified to do otherwise. Okay, in this problem, a health economist has been analyzing healthcare in the fictional country of Caucasia. In this work, she found that there are 57,000 high-risk Caucasians. Someone's at 57,000 right here. And 14,000 low-risk Caucasians. The average cost of medical treatment is $14,499. Now, we're going to assume that doesn't change whether you're high risk or low risk. The procedure costs what the procedure cost. The price is the price, right? No matter who you are. Now, the low risk Caucasians' probability of needing this medical procedure is 0.09. The probability of a high risk Caucasian needing this procedure is 0.14. Now, the next thing I want to do is want to use this equation down here to calculate what's called the actuarially fair health insurance premium, P. This first part is 0. Why is it 0? Because this right here is the probability that you need the procedure. This is the probability that you do not need the procedures. This is the probability of the complement event. Now, for low risk people, that probability is going to be 0.91. So if you don't need the procedure, you're not spending money on the procedure. So this first part's going to be 0. Now, if you're going to get the procedure, well, that procedure is going to cost you this amount. If you're paying a deductible on the procedure, this is your out-of-pocket expense. This is the total cost of the procedure. The difference is what the insurance company pays. Well, we're going to assume that this part is 0 for this problem. We're going to assume that is 0. The insurance company's got to cover, if the deductible is 0, the insurance company's got to cover 100% of the procedure. Okay, so this is how you calculate the actuarially fair health insurance premium. For the high-risk individual, the probability of not needing the procedure is 1 minus 14%. We're going to multiply that by 0 because if you're not having the procedure, again, you're not spending the money. The insurance company's not spending any money on you for the procedure because you didn't have the procedure. We're going to add that to the probability of needing the procedure, which is then multiplied by the cost the insurance company has to pay. And the deductible here is 0. So this would be called 100% insurance or full insurance. And that premium for high-risk people is $2,029.86. Now, the cool thing is I can just drag this over here. When I multiply the cost of 0, because here the insurance company is not spending any money on the procedure because you didn't have the procedure. So we're multiplying 0 times the probability of not needing the procedure. And then we're taking the probability of needing the procedure for low risk people, which is 9%, and we're multiplying that by how much the insurance company's got to pay for you to have that procedure. And that's the $14,499 minus the deductible. So again, this is full coverage or 100% insurance. So the low risk people have a lower premium than high risk people. Why is that? Well, high risk people are going to use insurance at a higher rate. So the cost of insuring them is going to be a lot more than the cost of insuring low risk people. That's why they have two different premiums. Now, one of the problems with these two different prices, if you're just some dude and you know that you're in the high risk premium or you're in the high risk pool, you're right. You want to kind of hide information from the insurance company, right? If you're smoking, if you're drinking heavily, if you're jumping off bridges with bungee cords strapped to your ankle, you're probably going to have more medical care needs than somebody that doesn't smoke, doesn't drink, and who eats healthy foods. You want to look as if you're in the low risk pool. Insurance companies want to find out if you're in the high risk pool. Because if you're in the high risk pool, they're going to charge you the higher premium. But you want to appear to them to be in the low risk pool. So if they ask you in a screening interview, do you smoke? You're probably going to say no. Do you drink? If you have 20, you're probably going to tell them 5 because you're trying to get into that low risk pool. Now, there are ways that companies could find out which pool you're in. Maybe they're allowed to collect information on you. Maybe they have you go to a doctor first, and the doctor screens your blood pressure, get your weight, calculates your BMI, and then sends that to the health insurance company. That's the way health insurance companies can find out which pool you're in. If you have a high BMI, you're heavy for your height, and your blood doesn't look very good because you don't eat right, you don't get enough exercise, you have high cholesterol, they can put you in the high risk pool. On the other hand, if your blood comes back looking good, you don't have a very high BMI, body mass index, your metrics look great, they can put you in a low risk pool. So there are ways insurance companies can get at this. Maybe with the internet today and social media, insurance companies might be able to figure out who you are on the internet. They can maybe look at your pictures that you post. I think today, this information is probably easier to collect than it was in the 1970s. In the 1970s, it was pretty easy to hide this information. There's a model that we're going to study later on, the Lemons model, that looks at asymmetric information. An example of asymmetric information on this problem is that the insurance company doesn't know which pool you're in. But I think that's much more difficult to do today. I think it's much easier for all this information to be transparent. I'm going to press enter here to make sure I got the correct answers. Now, because the health insurance premiums were actuarially fair, all 57,000 high-risk Caucasians purchased the insurance. Now, this is a simplified model here. To make it more realistic, we need to add a utility function in and maximize the utility function with respect to a budget line. But I just want to keep it basic because I think this model teaches how this is kind of like done on a very basic level. So because the premiums were actually fair, all 57,000 high-risk Caucasians purchased the health insurance at a cost of $2,029.86. And all of the 14,000 low-risk Caucasians purchased health insurance policies. That cost $1,304.91. Now we're going to use this information. This is what we observe in the real world, right? We've got these 2 points. We know how many people are insured total. The total number of people insured is this plus that. And then we got 2 premiums, 2 prices. So if we got 2 prices and we have the total number of people who are enrolled in each, and we have the total number of people who are insured, we can come up with a demand curve. We can estimate a demand curve. And we're going to estimate the demand curve over here. If everybody was charged this premium, who would insure? That was the only choice you had. Only the high-risk people would insure. If the premium was set at this for everybody, who would insure? Well, these people would definitely insure because they were going to insure at the higher premium. Because this premium is actually fair for low risk people, they insure too. So these two numbers, these are the quantities demanded at these two different premiums. Now we can double check or work, make sure it's right. I can copy this into here. I can copy this into here. Then I can press enter to make sure that I'm doing it right. We use this information where we have these two groups of people paying these two premiums. We observe that in nature. We observe that in the real world. We translated that to our demand schedule. We're going to use this demand schedule to estimate the equation for demand. Now, before we move on, what we have to do here, Excel gets confused when there's data in a table that's 2 by 2. Excel doesn't know if this is the X values or if these are the X values. So what we need to do here is we need to put in a row, a temporary row, and Excel will interpret that as these being the X values and these being the Y values. So what I'm gonna do now is I'm gonna highlight all 6 values. I'm gonna go up here to insert. I'm gonna click on charts. I'm gonna click on scatter with no line. And then here's my scatter plot. Okay, so what I need to do is I can delete these values right here. Now I have a demand curve that will be made when I connect these two dots. And the way to connect the two dots is to right click, add a trend line, click on display equation on chart. Now before I go, I want to increase the number of decimal places. I'm going to change that to number and change this to 6 because I need 6 decimal places. I'm going to delete the chart title. Okay, one last thing I want to do before I finish this up is I'm going to add a row here. I'm going to type a 0 here. I'm going to take the equation. I'm going to grab this equation here. I'm going to copy it. I'm going to double click in B4. I'm going to change this X to times. Then I'm going to click on this A4, which contains the 0. And I'll delete the comma. And then I'll add this point out here. This point is the intercept of this equation. Now, technically speaking, all the points on this dotted line from here to here, that's called extrapolation. Any interpretation of the line outside of these two dots is actually statistically maybe inappropriate. We're going to ignore that. We're going to assume that this is our demand equation for health insurance in this fictional country. Now, when I paste that equation here, this first number that I'm highlighting, that's the intercept, the one with the comma. I'm going to Control X that. I'm going to cut it. I'm going to delete the plus symbol and the X. I'm going to delete the equal sign and a space. I'm going to press enter. And the result gives me the slope, right? The slope is a negative 0.051782. I'm going to paste the value I cut from that equation, Control V, to 6 decimal places. Then I'm going to delete the comma just to make sure that sometimes MyOpenMath does not like commas and numbers. I'm going to press enter. So I have the intercept to 6 decimal places. And I have the slope to 6 decimal places. And when I press enter, it automatically draws my demand curve in this graph. The y-axis is the premium, and the x-axis is the quantity of policies that are issued. Now, if we interpret this line as a demand curve in Principles of Microeconomics, we can answer the questions below. And one of the interpretations of the demand curve is that it represents a queue that sorts Caucasians who have the highest willingness to pay up here, the y-intercept, to down here to the Caucasian that has the lowest willingness to pay. Now, it doesn't have to be willingness, it could be ability. So sometimes they call it ability to pay, or willingness to pay, regardless of what you want to call it, that willingness or ability tends to correlate with income. People that are really, really wealthy, who have high incomes, they have the ability and the willingness to pay higher premiums on average than people who are poor or have low incomes. So to calculate the price, the maximum price the consumer with the highest willingness to pay is I'm going to type a 1 right here. The 1, if you remember what we call the demand curve is a Q that sorts people from the highest willingness to pay. That would be consumer 1. And then I'm going to copy the equation from the chart. I'm going to paste it right here. I have the equal sign in there. There's no space in front of the equal sign. I'm going to delete the space there. I'm going to change the X to times A6. So what this does is it multiplies this negative slope by the value of 1 because 1 is in the box A6, right? And then I'm going to delete the space here. I'm going to delete the space here. I'm going to delete the comma there, and then I'm going to press enter. And it's going to calculate the maximum this person is willing to pay. This person's number 1 in willingness to pay. They're at the head of the line. They have the highest willingness to pay. And this person is willing to pay that amount. Now, the thing is, this dot right here, this middle dot, that corresponds to a premium around $2,000. The height of this dot is that premium. The height of this dot is that premium. So another thing we're going to assume is that every point along the demand curve from here to there, this line is populated by people who are in the high risk group. Where this dot is located on the horizontal axis, that's located at 57,000. Because 57,000 people are paying that insurance premium. Here, if you subtract all the people that are insured from this value, you get 57,000. So this value here is 71,000. This value is 57,000. The difference in those two numbers is 14,000. So there are 14,000 that populate the line from this dot to that dot. And these people are assumed to be the low risk Caucasians. And these people are considered to be the high risk Caucasians. High risk Caucasians all pay the same premium, the higher premium. And so this person is willing to pay that amount, but only has to pay that amount. So this person has consumer surplus. They feel good about the deal because they would have paid almost 5,000, but they only have to pay just over 2,000. So this person feels good about the transaction. This is that person's consumer surplus. Now, here's a little trick that I'm going to show you. First, I'm going to reduce the number of decimal places here. Number, change it to 0 to kind of clean it up a little bit. Another thing I'm going to do is I'm going to copy this chart to show you how this works along the demand curve. Now, in the second version of the chart, I'm going to click on the chart. I'm going to pull these boxes down to here. Then I'm going to collapse these boxes into one row. And that's going to leave one dot, right? Control C that chart, click on this chart, and Control V it. And notice what you see here. There's a box behind this blue dot. And notice what happens to the box when I increase 1 to say 2. The maximum price the second person is willing to pay came down a little bit, a tiny amount. And so too did the consumer surplus. But we're talking about 20,000 people from here to here. So going from 1 to 2 is not going to make a big difference. The price that they're willing to pay doesn't change much from the first to the second to the third or to the fourth. We're talking about pennies here. Let's do this. Let's change this to 1,000 and see what happens. We're talking about the consumer with the 1,000 highest willingness to pay. Notice what happened to this orange box. Now you can see it peeking out from behind this blue dot. That's the intercept. This orange box here is modeling this person's behavior. They're willing to pay that much money for health insurance, but they only have to pay that amount. So their consumer surplus is their difference. Now, if I change this to 10,000, see what happens. This orange box is moving down this line. And as we move down the line, the maximum they're willing to pay comes down. And so too does the consumer surplus. And that continues to happen as we get further and further down the demand curve. When we get to the 50,000 consumer, that person's willing to pay at most $2,300, $2,400, but they only have to pay $2,000, just over $2,000. So they feel good about that transaction. And as a result, their consumer surplus is almost $400. Now, when we get to the marginal high-risk Caucasian, the 57,000 high-risk Caucasian, the premium they're willing to pay is a penny more than what they end up paying. And as a result, their consumer surplus is zero. Now, the reason why it's not zero is because I'm rounding these values to 6 decimal places. If I didn't round it all, this would be zero. So the maximum price to consumer with the 57,000th highest willingness to pay is what? Well, that person's willing to pay that amount. They only have to pay that amount. And the difference in the two is 1 penny. Marginal consumer has 1 penny in consumer surplus. Now, policies are rounded to the nearest dollar. The consumer surplus can be zero. Now, the next question is, what's the maximum price the consumer with the 57,000 first, the next person's willing to pay? What's that person's willingness to pay? The highest they're willing to pay for health insurance. Between this blue dot and that blue dot, we're talking about low-risk people. So what we have to do is we have to change the consumer surplus. Low-risk Caucasians pay the lower of the two premiums. And we're talking about the next consumer, right? The very next one. The very next one is willing to pay $2,029.82. It's just under the premium that everybody else has to pay. But it's above what low-risk people are charged for insurance. And the difference in those two is the consumer surplus, right? All the lower risk people are paying that premium. And so this person has a consumer surplus around $725. Now, what about the maximum price to consumer with the 71,000th highest willingness to pay? I'm going to change this to 71,000. Now, this person is going to be the marginal low risk Caucasian. And they're willing to pay a penny more than the actual policy. The actual policy is that amount, and they're paying a penny more. Now, the total consumer surplus measures the total benefit that accrues to both what? High risk and low risk Caucasians. Why? Well, both are buying health insurance. One is buying a health insurance premium that is higher than the other, but they're both in the market purchasing health insurance. The consumer surplus of the high-risk Caucasians is this red triangle. The consumer surplus of the low-risk Caucasians is this red triangle. The reason why that is because, remember, this line segment is 14,000 people long. This value is 57,000. And this value is 71,000. And the difference in those two numbers is the length of this triangle, which is 14,000. And the length of this line segment is the 57,000 people who are low or high risk Caucasians. So this is the total consumer surplus here. And what this illustrates is that there is a marginal consumer amongst the high risk pool, and there's a marginal consumer amongst the low risk pool. So there's a high risk marginal consumer and there's a low risk marginal consumer. Now, because the above premiums represent the lowest prices health insurance companies are willing to accept for selling policies to low risk and high risk individuals, their profits are negative if the premiums were lower, You can think of the two representing the supply curve for the two different groups. So under this interpretation, the supply curve for the high-risk group individuals is a flat line at a price of the higher premium amount. When I press enter, the red triangles are gone, and I draw in this blue line with the dashed line coming down from their intersection. At this intersection is the 57,000 high-risk Caucasians. The supply of high-risk policies and demand meet at a quantity of 57,000. Policies sold to high-risk individuals, ones that tend to use healthcare more often. The supply curve for low-risk individuals is a flat line, perfectly elastic, at a price of the lower premium. And the lower premium is $1,304.91. Entering that value draws the second supply curve. And it and the demand curve meet at 71,000. According to this diagram, the supply of low-risk policies and demand meet at a quantity of 71,000 policies, and 14,000 of them are sold to low-risk individuals. The economic model that describes charging two different prices to two different groups of customers for the same product is called, well, it's not perfect price discrimination. Perfect price discrimination is where companies want to charge individuals the maximum price they're willing to pay. So they're trying to grab all of the consumer's surplus. So the area between a demand curve and a supply curve is, which is normally total surplus, but the consumer surplus is zero, so total surplus would equal firm surplus. So it's not perfect price discrimination. It's just price discrimination. And examples include student discounts, senior citizen discounts, airline ticket pricing a month before a flight and on the day of the same flight, loyalty programs, coupons, pricing for the peak and pricing for the off-peak hours, and then geographical price variation. In the figure model, the demand and supply of movie tickets, with the blue line being young adults and the green line being senior citizens, would you consider the pricing to be illegal discrimination? That's an interesting question. If young people use insurance less than older people, if this were the premium of people in their 40s and this were the premium of people in their 20s, would you consider that illegal discrimination? Would you feel comfortable paying this premium to help benefit the older group? Some people might say yes, some people might say no. Suppose Caucasia passes a law that bans gender indexing. Gender indexing is where there's only one pool. You don't have a male pool or a female pool. You have just one pool. Females tend to use healthcare more often. The company's going to spend a lot more money on their care on average than on a male. And so health insurance companies in the past have charged people different premiums based on their gender. Now, to comply with this law, health insurance companies pool all citizens together. The expected number of high-risk individuals needing medical care equals what? High-risk people in the pool needing the procedure, its expected value is going to be the product of these two numbers. And the same goes for low risk. It's going to be the product of those two numbers. I'll call that NP for needing procedure. The total number of people we expect that need the procedure is going to be the sum of the two. So the expected number of high-risk individuals needing the medical care equals 7,980. The expected number of low-risk individuals needing the medical care is going to be 1,260. Press enter. Make sure we got the numbers right. There are a total of 71,000 people in this new pool. And we expect how many do we expect to need the procedure? 9,240. So the pooled probability of Caucasians getting ill would be the ratio of these two numbers. We're going to put it right here. And notice it's pretty close to that number, but it's between these two. That's because this is a weighted average of these two, and it's weighted toward the bigger population, high risk. So the pooled proportion is 1301. And we got to round that explicitly to 4 decimal places. Okay, so to answer this question, all we have to do is drag this one to the right after I get the cost of healthcare. Now I'm going to double check to make sure this is 4 decimal places. I got to round this explicitly to 4 decimal places. So what I want to do here is I want to put round and then go to the end of the ratio and type 4 and then close parenthesis. So equal round the ratio, the fraction, comma 4, close parenthesis. And that changes my calculation. So now the actuarially fair insurance premium is that value. And to get this value, again, we're just using this equation here, right? This first part is 0. So essentially, we're just multiplying the probability of needing the treatment by the cost because the deductible is 0. Because this pooled health insurance premium exceeds the maximum premium, notice that it's the premium, the new premium is between these two. So what's going to happen here is the low risk people are going to say, I'm not buying insurance. Meanwhile, the high risk people are going to say, hey, this is a good deal. In this last column, I got pool star. What ends up happening here is the low risk people leave. Now, because only high risk people are in this pool, the probability of needing the procedure is 14%. 0 low risk Caucasians are going to pay a premium more than $1,304.91. 57,000 high-risk Caucasians purchased the insurance. And this results in a new probability of needing the procedure of 0.14. Now we're going to use this probability with this premium to calculate the net income of the company. We can calculate it for all these scenarios. And the way you calculate it is you just take the premium that is collected by the insurance company from everybody that's insured. You subtract off the cost of the policy. Now, in the worst case scenario, everybody gets the procedure. So everybody pays the premium and the insurance company's got to cover the cost of the procedure for everybody. And if that were the case, the insurance company would lose lots of money. But insurance companies don't expect this outcome. They don't expect everybody needing the medical care. They don't expect it because only a fraction of the people who are insured are going to need the procedure. So multiplying this by probability of needing the procedure and then adding to that the premium that's collected from everybody who doesn't need procedure, multiplying that by the probability of people not needing the procedure gives us the net income of the insurance company. And it's 0 for the high-risk premiums when different premiums are allowed to be charged for high-risk and low-risk occasions. The expected net income is 0 for both of them. If the low-risk people had not exited the insurance pool after the health insurance reform was put in place, then the insurance company would be breaking even on those policies. However, that's not the case here. The 14,000 low-risk Caucasians exited the pool. The government forces the insurance company to keep the pooled premium at $1,886.32. With all the low-risk people exiting the pool, the probability of the medical treatment costing $14,499, the probability of that expense is 0.14. And that would result in a net income equal to a negative $144. To 2 decimal places, a negative $143.54. So the insurance company is going to go out of business here if it can't get an authorization to raise the health insurance premium. To avoid bankruptcy, the health insurance company lobbies the Caucasian government to A, allow it to increase the premium it must offer to all Caucasians, or B, pass a law that requires everyone to purchase health insurance. The lobbying results in the Caucasian government choosing A. So it's going to, instead of passing a law that requires everyone to purchase health insurance, it's going to go with A first. It's going to permit the health insurance company to stay in business by adjusting the premium. Since this insurance pool lost all the low risk Caucasians and ended up with just high risk Caucasians, the insurance premium is going to be the one it had chosen when it could charge a premium, two different premiums for high risk and low risk Caucasians. So given the cost of the medical procedure is $14,499, the probability of needing that treatment is 0.14 because all the low risk people left the pool, leaving just high risk people. The insurance company wants to charge that premium because when they could charge two different premiums, one for high risk and low risk, all of the high risk Caucasians insured at that premium. And that was a premium that made their net income zero. So what we have to do is we have to slide this box over to here and slide this box over to here. And you're going to see that we now break even at that insurance premium. This results in the two supply curves up here becoming one, which is a flat line at a price equal to this premium. When I press enter, you'll see the two supply curves have become one at the premium such that the insurance company just breaks even. This new supply curve crosses demand at 57,000. So the result of the reform will cause the insurance company to go bankrupt at that pooled premium of $1,886.32. To avoid that, the government allows the insurance company to raise the premium up so that they just break even. Having that premium at this high level eliminates everyone from the pool except the high risk. According to this diagram, the supply of policies and demand meet at a quantity equal to 57,000 policies sold to high risk individuals and zero policies sold to low risk individuals. We call it total consumer surplus, measures the total benefit that accrues. Well, in this situation, remember, there are no low risk people in the insurance pool. They left because the premium was too high for them. And as a result, the premium went even higher. So the only people in the market that are insured are high risk Caucasians. This red triangle represents that consumer surplus of just the high risk Caucasians. If willingness to pay and income are perfectly correlated, the marginal consumer, remember, this line segment corresponds to the number of high-risk Caucasians there are. So the marginal consumer now is this last high-risk Caucasian. According to the model, the health insurance reform was intended to make health insurance fair by lowering premiums for high-risk individuals and raising premiums for low-risk individuals. Instead, the pooled premium ended up equal to the premium high-risk individuals were paying before the reform. This resulted in 100% of low-risk individuals choosing to be uninsured. According to the findings of this model, with the health insurance reforms that we analyzed, despite the good intentions of the change in the law, the reforms should what? Should they be enacted if young adults are low-risk Caucasians and middle-aged adults are high-risk Caucasians? Should the law force young adults to pay a higher premium so that the middle-aged adults are paying a lower premium? Should that be the case? If that happens, young adults will choose not to insure, and the premium that middle-aged adults have thought they were going to get, they're not going to get because their premium will be the same before and after the reform. All it did, according to the model, is uninsure young adults. So I would say the model is saying should not. The reforms should or should not be enacted if men are low-risk Caucasians and women are high-risk Caucasians. So the law, again, if you remember, is going to lower the female premium and raise the male premium so that they're equal. What the analysis showed is that the men uninsured, and because they left the insurance pool, only women were left, and they're the high-risk Caucasians. So their premiums were the same before and after the law, and men uninsured. So I would say the model says should not be enacted. The reforms should or should not be enacted if teachers are low-risk Caucasians and police officers are high-risk Caucasians. Well, the teachers are going to have a really much safer job than police officers. If police officers are running down a suspected criminal, they might tweak their knee. They might break a leg jumping over a roof from one building to the next, trying to chase down a suspected criminal. They might get in a car crash as a result of a high-speed chase. So they're going to be using healthcare more often than teachers. Should they both pay the same insurance premium? If teachers who are low risk pay a lower premium and police officers are high risk and they pay a higher premium and they're adjusted in a way where both premiums are the same, teachers will choose to be uninsured, leaving high risk Caucasians in the pool, which means the premium they pay will be the same as it was before the reforms as it is after the reform. So I would say the model saying should not be enacted. Now, as I mentioned earlier, we're kind of assuming there's perfect information here, which I think it's easier to assume that now in the age of information, the age of the internet, in the age of electronic information that can be easily transferred from doctors to insurance companies. So I don't think the asymmetric information is as much of a problem as it was in the 1950s and 60s. So when we get into chapters 8, 9, and 10, we're going to introduce this concept of asymmetric information. Suppose the health insurance companies cannot know your health status. And as a result, maybe they put you in these groups. Maybe you're a really healthy female, but because you're a female and they can't get the information, they charge a higher premium than a female that has lower health capital. Maybe you're male, and because you're in the male group, you pay lower health insurance premium, but maybe you're a male that eats too much pasta, doesn't get any exercise, while other males in this insurance pool are taking care of themselves. In the next chapter, we're going to look at the effects of asymmetric information on health insurance.